Today we're going to learn how to draw Lewis dot structures. To be able to draw a Lewis dot structure, you have to do a few things first. First, find the element on the periodic table that you'd like to work with. Next, determine the number of valence electrons. This is how many dots you will draw for your Lewis dot structure. Questions are, why do we have Lewis dot structures? A lot of people ask. Well, it's very simple. Lewis dot diagrams or Lewis dot structures easily show the number of valence electrons that an atom has available for bonding. Remember earlier this week we talked about the fact that valence electrons are used when atoms bond together to make new substances. And they only use those valence electrons. They don't use any of the other electrons. They only use the electrons in the outer shell. So by drawing a Lewis dot diagram, you can see very quickly how many valence electrons an atom has. And we're going to talk today about valence electrons and why the number of valence electrons is very important. So first, you're going to take your element that you're working with and you're going to find out which group or family, which is a column, your element is in. And just a reminder that a column or a group or a family are the ones that go vertically, so up and down. And again, just from earlier this week, this will tell you the number of valence electrons that your element has, because you are only going to draw the valence electrons. So remember, the numbers that are found here across, or the group numbers, those group numbers are the same as the number of valence electrons for all of the elements found in this column. So just to review, and you've seen this slide before, okay? Each column is called a group or a family. The group number tells us the number of valence electrons, and remember that your periodic table over here does not say 3 through 8, it says 13, 14, 15, 16, 17, and 18. So when you get to those columns, remember what I told you before, you look at only the ones place, and the ones place will tell you the number of valence electrons. Also remember what you learned before, helium is found right here on the periodic table in group 18, but helium is that exception. It only has 2 valence electrons. But remember, it's placed in this group with the noble gases because of its full outer shell. That's what it has in common with all the rest of the atoms in the noble gas group. So to start, for Lewis dot structures or Lewis dot diagrams, you write the element symbol. So if we're going to do carbon, we would put a C on our paper. Now if you look at carbon on your periodic table and you go up to the top of its column, you see that carbon is in group 14 or 4A. So again, on your periodic table with the 14, we just look at the ones place and we see that carbon has 4 valence electrons. So those 4 valence electrons are what you're going to show in the Lewis dot diagram. So with Lewis dot diagrams, you can start wherever you'd like. You can start at the right, you can start at the top, and you're going to start placing dots. Now we have 4 valence electrons, so we need 4 dots. So I started here. You place 1 dot, and again, it doesn't matter whether you go clockwise or counterclockwise, but once you start moving in that direction, you have to continue moving in that direction. And you just take a dot and you place it on all sides of the symbol. Okay, picture the symbol as being in a box. You may not put the dots at the corners, but you must put the dots on the sides of the box, the sides and the top and the bottom. Okay, not over here on the corner. So since carbon has 4 valence electrons, you will have a dot on each side of the symbol. Then you check your work. Again, you look at the periodic table and make sure that your element is in the group with the correct number of valence electrons. So again, we're going to check and make sure that carbon is indeed in group 14 or 4A, and make sure that you've only drawn 4 dots, one for each valence electron. And so that is the correct Lewis dot structure for carbon. So this is very simple, and there's a list of some that you're going to work on by yourself. But let's take some from the list and do them together first and make sure that we completely understand. So the first one is hydrogen. So first on your paper, I want you to write the H, the symbol for hydrogen. And just remember that wherever you start placing your dots is fine, and whichever direction you choose to go is fine, but once you start moving in that direction, you have to continue. But hydrogen is very simple. If you take a look, hydrogen is in group 1, so it has only one valence electron. So hydrogen, okay, will look like this. You just start on the right and you place your dot, and you're done. So that Lewis dot structure just says to us, hydrogen has one valence electron. But let's move on to sulfur, and let's do that one together too. So on your paper, just write an S for sulfur, and I want you to look at your periodic table and find out what group sulfur is in. Sulfur is in group 16 or 6A, so we have a few more dots that we have to place. Sulfur has then 6 valence electrons. So again, let's start. We can start here and let's place 1. And I'm going to go clockwise. So we have to go clockwise the whole time. So 1, 2, 3, 4. Now, here's what happens when you fill all sides. Now you start going around again, but you begin to place the dots in pairs. So this will be 5 and 6. And then you're done. Again, double check, make sure you have 6. There's 6 there. And that is the Lewis dot structure for sulfur. So take a look at the rest of the elements that you have on the list. Okay, you have lithium, phosphorus, chlorine, and aluminum. I want you to try those Lewis dot structures on your own, and then you can talk about it as a class or put the answers up on the board. Now let's talk about an exception. Okay, so we've practiced putting the Lewis dot structures on, and we usually go all around each side, placing our dots, either moving clockwise or counterclockwise, but there is one element who is an exception. Okay, and our exception is helium. So we're going to do that one together on this slide as well. So go ahead and write helium on your paper. And hopefully you remember that earlier this week we said that helium is an exception to its group because its group is the noble gases, and the noble gases are called the noble gases because their outer shell is full, and everyone in that group has an outer shell with 8 valence electrons. However, helium does not have that many electrons. It has 2, but 2 still fills that first outer shell because the outer shell only holds 2, which is why helium is also a noble gas. Its outer shell is full. But when we want to show this on a Lewis dot structure, then helium will not look like this. We want the dots to be placed to represent the fact that it does have a full outer shell. And here's why. Every atom wants to have a full outer shell. It wants to have that magic number of 8 because once its outer shell is full, it is a stable atom. That means it doesn't want to bond with anyone anymore. It's happy. 8 is the magic number, and it makes all atoms happy. Now, since helium has a full outer shell, even though it's not 8, it's happy. It doesn't want or need to bond with anyone. So this Lewis dot structure for helium is incorrect because we're not representing the fact that it has a full outer shell. So what we're going to do is we are going to change this a little bit. So instead of showing the Lewis dot structure like this, we're going to do it a little bit differently. We're actually going to take and we're going to place our dots both next to each other right up here. Helium has a full outer shell, but it does not have 8, even though it's in group 18. It has 2, but those 2 fill the outer shell. So we're going to place helium's 2 valence electrons right next to each other above the symbol, okay? Or next to it would be fine too, as long as the 2 are right next to each other on one side to show that helium has a full outer shell and it does not need to bond with anyone because its outer shell is already full. So helium is the only different one. Let's take another noble gas and look at the Lewis dot structure though. So argon is also a noble gas. If you take a look, it's also in group 18, which means it has 8 valence electrons. Now for argon, you would still do this the same way. Okay, you would start here or at the top and you would go all the way around, placing your dots, and so far we're at 4, and then you just start to double up. So again, argon is also a happy atom because it has a full outer shell. It holds 8, that's the capacity. So argon also, as well as the other noble gases, do not want to bond with anyone. It has all of the electrons that it needs. So argon's Lewis dot structure would look like that. So go ahead and practice the other ones again and make sure that your Lewis dot structures are correct. So this is just showing elements 1 through 20. We only usually do 1 through 18 in 8th grade. Okay, we already talked about what the Lewis dot structure should look like, and so on this slide, we're showing you the correct Lewis dot structures for each one. So you can pause it here if you'd like, or if you've already gone over all of them, this is just here for your reference. So notice that all of your noble gases here, okay, have 8 with the exception of helium, which has its 2 dots at the top together, showing that it has a full outer shell and does not need to bond with anyone to fill it. Okay, so further information as to why we show and have Lewis dot structures. So basically, let's take our most easily remembered compound or molecule, and that's water. Water is made of 2 hydrogens and 1 oxygen atom. And so if we took their Lewis dot structures, you can see hydrogen has 1 valence electron and oxygen has 8, excuse me. No, 6. Sorry. So if you take the 1 from this hydrogen and the 1 from this hydrogen and the 6, so see there's 2 and 2 and then another 2 here, and we want to show how they bond together. Now you're going to do this more in chemistry, but just so you have an understanding of why we look at Lewis dot structures. We're taking and we're showing how hydrogen and oxygen bond together to form water. And so here we go. The hydrogens easily fit on each side of the oxygen to form H2O, or a water molecule, because these valence electrons here are being shared with oxygen. Because again, every atom wants to have a full outer shell and to be happy, and the full outer shell is 8. And so here you go. With the addition of the hydrogens together and the oxygen, they all have 8 electrons now. So this was just a quick lesson about Lewis dot structures and how you can quickly and easily represent the valence electrons found in an atom.